Okay, so that's the Swedish field flora. It's a more modern field guide.
Yeah.
So when we do our AI algorithms with the video from the drones, we ideally want to be able to do taxonomies.
So in this one, you have a key in the beginning.
Yeah.
So
this is the decision tree, basically.
Yeah. And so then you know where to go.
Yeah.
And then you have...
and the key is based on various morphological features of leaves and flowers and things like that.
Exactly.
Yeah.
So most plants are difficult to key when they are not flowering, for example, because you need to look at flower traits.
Yeah.
But then you go here and you can verify, you see, does it look reasonable with the distribution map?
Okay.
And you have the features described.
Well, that's quite a challenge.
Yeah.
If you want to do GPS plant maps at centimeter resolution, which is one of the prototypes we want to build at WakeWorks with our AI engineering scientist, I think it's quite a challenging problem.
I mean, there's only 37 orders and 116 families.
Yeah.
So
that, in that sense, the support set is finite.
Yeah.
Yeah. I think one has to do
and
Linnaean taxonomy back-ended or backboned image classifications.
Yeah, I mean, getting to the order is quite easy to learn.
Yeah. And these are various images, so one can actually try and scan this to build some possibly training data. But it will be very difficult because one has to actually look in the key and actually look at the plants as they're growing.
Yeah.
And then try and build a training data set. I mean, that's a pretty serious X-job problem.
Yeah.
Hopefully we get a bunch of X-jobs to help out this summer.
Yeah.
All right. It's already 2 minutes and 2 seconds. Anything else you want to say?
No, just repeating this, that the life stage is important. So many plants you can't really identify when they're not flowering.
Yeah, that's true.
So you can get them to the order and to the family, but not to the species. Like these, for example, you can't really tell these apart.
Yeah, and also when you fly over a drone and you see a leaf like this among many leaves, you have to first do image segmentation to be able to identify the boundaries, and then and then from the image segmentation of the boundary of the leaf, one has to further do taxonomies, classification of the leaf morphology, and it's pretty involved. Unfortunately, it's not done because there's very little money in it. But of course, once it's done, there's going to be quite a lot, right? Because then we can map each of these plants to exactly where they are, and then study their actual special relationships they have with the known
and also
fungi and bacteria.
If you look at the geographical distributions here, for example, you see there's only one of these that could possibly maybe grow here where we are.
That's true.
And that's even question. I think it occurs here, Bacnelica, but the others don't even occur here.
Yeah,
so if you look at geographical distributions, I mean, you're already down to... We're here in northern Sweden. We're down to maybe a third, would be my rough guess, of the plants.
This is basically like scanning each of these and then and then automatically classifying, the probability of occurrence of each of these. So one has to actually scan and do some serious image processing of the text itself, right, to extract.
Well, I mean, basically...
No, what I mean, image processing of the information.
Yeah, but all of this is available online, of course. I mean, there are online floras.
Okay, that's
so
probably
den virtuella floran, the virtual flora, is a very good site.
Okay.
That has all the species in Sweden and with distribution maps and photos and descriptions,
really
etc.
We should start there.
Yeah.
Okay. Sounds good.